Let's solve part B now. So this is the integral that we have over here, and again we have to use the substitution rule. It looks a bit more complicated because the terms have logarithms and square roots, but again, this whole notion about substituting will become easier with more training. So it's about seeing relationships between the term that we substitute with its derivative, so that after we differentiate, we must see a connection between that term and whatever is left over here. Now, before solving, let's use intuition to see something similar. It just has to be something similar. So for instance, if we would integrate this term over here, ln of x plus square root of x, what's the derivative of ln of x? That's 1 over x. And what is the integral of square root of x? That's 1 over 2 square root of x. Now, this is very similar to what we have left over here, because this is 2 over x and this is 1 over square root of x. So there's something with the coefficients that we'll have to play with, but the overall big picture is there. It's gonna make a sense. It's gonna be a connection. So let's try connecting it that way. We will substitute u with ln of x plus square root of x. Now with that said, let's do the du thing. So differentiate u with respect to x, du over dx. We differentiate this thing separately, so that's 1 over x plus 1 over 2 square root of x. Now let's take dx on the other side by cross multiplication. So we're left with du equals to 1 over x plus 1 over 2 square root of x multiplied with dx. Okay, now with that said, what do we have at the moment? Well, when we substitute u over here, right, we have dx times this expression, but we can see it's slightly different from what we have in the beginning, because here we have 2 over x and 1 over square root of x. Well, the relationship is that this is our expression multiplied by 2. Let's multiply it by 2 both sides, so we could substitute it there. We will have 2 times du. Let me change colors for that. We will have 2 times du. So 2 times du equals 2. What is 2 times 1 over x? Well, that's just 2 over x. So there we go. Our first term is there. Plus 1 over 2 square root of x times 2. Well, 2 and 2 is going to cancel out, and we're left with 1 over square root of x. And then we also multiply that with dx. Now we could see the relationship that we were looking for. This thing over here is the exact same thing as here. So we could substitute it, right? The purple thing that we just circled is just 2 times du. So we have 2 times du over here. And on the other side we have 1 divided by u, because that's how we substituted u. With that said, let me just zoom out to get some more space. With that said, we're going to substitute and see how this all works out. So we will have the following. We will have the integral of 1 over u multiplied with 2 times du. 2 times du. That's literally what we broke it down to. We went from all this thing to just this thing. Okay, what do we have now? We have a constant in here, so that's 2. Let's take it out, because we can do it. And we are left with the integral of 1 over u du. Now what is the integral of 1 over u? Well, we're going to use our logarithmic property. That's just 2 times the ln of absolute value of u plus a constant. And this is it. We just have to substitute the u with what we did in the beginning. And in the beginning, the u was equal to ln of x plus square root of x. So we substituted over here, and we're left with 2 times ln of, and in absolute value we must write all that term. So we have ln of x plus square root of x in absolute value plus c. Let me just go back to that, plus c, and this is it. Hope this makes sense, and we are done.